Okay, hello everyone. Thanks for inviting me. I'm going to talk about zero knowledge and what Harmony is trying to achieve with zero knowledge. So let's start. First, this is it's not very new, but it's kind of new. And it's a very complex. So I'm going through the basics. So apologize if you already know the basics. So I want to start with the basics. So first, what is zero knowledge proof, right? It's just a way so one party can prove to another party, in this our case is the prover and the verifier, that she knows a secret without actually revealing the secret. Right? I just need to show that I know the secret, and the other part to be convinced that I know the secret without telling the secret. So that's the main idea, right? So yeah, so the zero knowledge proofs. The idea is that you need to prove the knowledge of a secret, that I know a secret without telling the secret. It's a special proof, type of interactive proof. It means that the interactive proofs have to be complete and sound. I will talk more later about that. And it's between two parts, a prover and a verifier. And it has a wide range of applications. And most of them are on the obvious side, that is security and privacy, but it also, in crypto, it also shows a better way to scale. So I also will talk about how zero knowledge can be used to scale blockchains. So this sometimes is very hard to understand, and there are many analogies to explain this. So I'm using the more common is Alibaba's cave. So in the initial story of Alibaba's cave, it's Alibaba goes to a market and thieves keep stealing stuff from them. So in this case, Vicky will be the Alibaba, and Patricia, the prover, will be the thief. So I will show you how this works. So Patricia wants to prove to Victoria that she knows. So in the cave, in Alibaba's cave, you see that it's a circle, a loop cave, that in the middle has a gate, that you only can open the gate saying the passphrase. In the story is open sesame. So the only way that so Patricia wants to prove Vicky that she knows the secret phrase to open that door, that gate. But she doesn't want Vicky to know the actual phrase. So Patricia proposed something. You, Vicky, stand in the entrance of the cave, and you tell me in which side you want me to come, A or B, and I will come out of that. So that way, I want to prove you that I can go both ways because I know the passphrase for the door. So Victoria stands and the first time says A, and Patricia comes through A. But if she only does this once, it's only 50% chance that he knows the actual phrase. But he repeats this many times. Patricia will prove Vicky that she actually knows the phrase. So Vicky say A, and Patricia comes out of A, B, and comes out of B, A. No matter which side, Patricia will only come from the right side. So after a number of times, Vicky will be convinced that Patricia knows the phrase, but Vicky never actually got to hear the phrase. So this way, this is a zero proof. So Patricia proved Vicky that she knows the phrase without never telling Vicky what the actual phrase was. So this is the more common way to explain zero knowledge. More in a more practical way and probably a little simpler is you go to a bar and the bouncer, in the United States, when the bouncer wants to know your age, you show him the whole driver license with your address, with all the information. But the only thing the bouncer needs to know is if you are over 21 or not. So if there is a way, if imagine an app that the app scans your driver license and only tells the bouncer yes or no. Because that's the only thing that the bouncer needs. Know if you are over 21 or not. So it's only a yes or no. So you don't need to show the driver license, your address, and your everything. You don't even need to tell him what their date of birth actually is. You just need to prove that you are over 21 or not. So that's another kind of way to see zero proof. So the Alibaba's proof is a zero knowledge proof because it's complete. It means if Patricia knows the secret word, she can complete the proof successfully. It's sound because if she doesn't know the secret, it's highly unlikely that she can prove that she knows the secret in multiple consecutive rounds. It's a zero knowledge because no matter how many times Vicky asks for, she cannot learn the secret. And it's non-transferable, so Vicky cannot use the proof to pretend to be the prover. So these are the reasons, the basics why Alibaba's proof is considered a zero knowledge proof. So a little more formal, completeness means that if the statement is true, an honest verifier will be convinced that this fact by an honest prover. Is soundness is if the statement is false, no cheating prover can convince the honest verifier that it is true, except with some very small probability. At zero knowledge, if the statement is true, no verifier learns anything other than the fact that the statement is true. So these are the basics of what a zero knowledge proof should have. So there, just talk up some zero knowledge uses. So the most common is identification, basically a system for two parties when the user identifies herself to the system in a secure way. It means that the third party listening to the conversation cannot later impersonate the user. And we can use zero knowledge for this because it will be possible to identify a user and the user to remain unknown. So I can say, this is me, and I have access to do this, but you don't have to know that I'm Boris. You just only need to know that I'm authorized to do some specific function. So there is a use for zero knowledge in identification in this. For network privacy, participants in a network can remain anonymous. But they can prove that they are the right interlocutors in the conversation. Is if you are a group of people is talking, you just need to know that, imagine the conversation is about engineering, you just need to know that the guys are engineers and they are, capable of having the conversation. You don't need to know the names. You don't need to know who they are. They just need to know that they know what they're talking about. So this is an approach for zero knowledge for network privacy. So it's basically zero knowledge can provide a way to do basic public and private key pairs. So it's a standard. So zero knowledge can be used to establish a public-private key scheme. So now for scaling blockchains. So zero knowledge. So the idea is that you can create rollups or layer 2s, so you can maintain the computation on the layer 2 and only leave the security to the layer 1. So zero knowledge can be used to facilitate that process of giving the layer 1 the control over the security. So the way we do this is since we can use zero knowledge to generate cryptographic proof that some computation have been performed based on some predefined rules, and these proofs can be generated programmatically and verified automatically. So the scaling, the potential of scaling lies in the proofs themselves, because the proofs are significantly smaller than the data they represent, and verifying them is relatively cheap. So it's like a way of compression. Since the proof is smaller than the data that you will need that represents, it will be faster. The process will be faster and lighter. So they don't really modify the fundamentals of the blockchains. They just rather change the purpose behind them. So instead of computing small payloads in the main chain, they verify exponentially larger payoff outside of off-chain. So it's a little complex, I know, but the idea is this, that the proof is smaller than the data that will require normally. So you can just verify larger payloads off-chain and then come back to the chain just to do the security. So that's the idea of how blockchains can be used, zero knowledge can be used to scale blockchains. So there are two schemes more common now to do this scaling. It's called snarks versus starks. So they are both succinct. This is the main feature here. That is mean that the proof is significantly smaller than the data it represents. And so it can be verified very quickly. So it's a non-interactive. It's between, only one set of information is sent by the prover. So it doesn't establish a conversation between two parts. It's non-interactive. No coming and going. And the argument of knowledge, the part of is that means that the proof is considered computationally sound. So that means that the malicious prover isn't likely to cheat the system without possessing the knowledge to support the statement. So it's basically the zero knowledge feature of the proof, right? The difference with the snark and stark is that the stark are supposed to be transparent. So this part is a little, so the snarks require that a ceremony is set up before. So the parts communicating need to set up like a basic round to run the proof. The stark doesn't need that part. I will talk a little more about that a little later. So this is what I'm talking about. Basically, what I just talked about this is in the slide. So the snark requires this ceremony every time you start the proof, right? So the stark doesn't need that ceremony. So it's supposed to be more efficient, but it also is larger in size. So I have so this is the snarks use 20% less gas. They have been around for a while, so there's a lot of documentation and a lot of developers doing this. Starks are news, but they don't require the ceremonies, and they are not vulnerable. In theory, they are not vulnerable to quantum. They are quantum resistant. So, but these are the two main parts. It's a matter of if you decide to go in this direction, try to do this, there are two options, and it depends on the product. You will use one or the other. So the reason we're talking about this is because Harmony is believe that the future of scaling relies on rollups, CK rollups, so we can create layer 2s. So it's a long path. There are not enough developers, and we want to bring more developers into this space. So we have not only done a lot of research on this area, we also opened what we call the Zero Knowledge University. It's an online course for someone developers who want to have market-ready products using zero knowledge. It's difficult to create products in this area. The use cases are still not necessarily clear. I personally am working on an NFT dropout system that allows you to be part of a NFT airdrop. Sorry, an NFT airdrop, and being completely anonymous. So you will receive the NFT, but no one knows that you have it. So when I did the Zero Knowledge University, that was my last project. So, but it's hard sometimes to define a product. So we want to take engineers and teach them how to all the parts of zero knowledge. It's a Web3 course. It requires Solidity. It requires the basic, but it also requires another set like WASM, like Circum. It's quite complex. So we want to train you guys to do this. And not only we want to train you, we want you to incentivize you to take the course. So I tell you what it means. It's an intensive course. It takes a lot of time. It's 7 weeks, and each week you present a project. The projects can be a little difficult, but we have industry experts. The leader is Haquan, that he's a Rhodes Scholar. So we brought a set of very smart people that knows a lot about this, and we want these people to be your guides, your mentors on this path to zero knowledge. And not only that, we want to incentivize you with money. So the course have several steps. The developers that start completing the steps, they get compensated with money. And then if they complete, they can apply for 2 things, $15,000 a year annual income for life, a UBI for life, if they finish the contract, or apply for a $50K grant. So that's the way we want to incentivize people to join the university. So just giving you guys money to complete the levels of the course and finish the course. There are some prerequisites. You have to do an initial project to make sure that you have at least the basics to enroll. The next cohort starts in 3 weeks in May. And this is the link to enroll. I can send this later if you're interested in enrolling the university. And not only that, if you are a software engineer and you feel that you don't have the basics, we are doing a pre-course. It's a 3 modules course. All of this, of course, is free. So we will cover in the pre-course all the basics you need to take the main course. Like the first one that is already rolling is Circum. And then we go to Web3 WASM. And then the last module, it will focus on the assignment you need to complete before to enroll. So we're doing 3 modules to make sure that if you are a software developer, you have to be a software developer. If you are just learning to code, I don't think you are not ready yet to do this. But if you are already and you need the basics, you can take the pre-course, and I think you will be fine to take the course. And you can enroll in this too. And yeah, hopefully it will be enough, and you can start this path on zero knowledge. So I don't know how much time I have how much I have left, but these are the basics. And Harmony is there. You can stop by and talk to us. I can give you a little more details. I try to compress this in small, but it's so much to talk about zero knowledge. And we enroll 100 people in Brazil 2 weeks ago on the pre-course. So and the feedback so far has been fine. So we're trying to get 2,000 people enrolled in this course. So please stop by. We can talk more about this, and I hope you can join. And yeah, we see you in the course.